Okay, you guys already have some basic concepts about forces. You learned basic definition about forces that push or pull is called force. All these basic definition you already studied in your lower secondary classes, right? So that was the basic definition, basic concept of force. We use forces in our daily life. While driving a car, there is a driving force. When we try to pull or push a door, so there is also a force. Same goes for the spring. There is also a gravitational force. These are the forces which we already studied in different chapters like mass and weight, the gravitational pull, and in moment we also studied about the force. So there are different concept of forces in this specific chapter. We need to study with the concept of direction. Also we need to study about the laws, and we need to study about the concept of spring, because spring is something different, because there is a compression and rarefaction process involved in spring concept. Then we will study the force in pressure, because the basic definition of pressure is force per unit area, right? So for the basic definition and the basic concept of the forces, so very generally we just simply write force as push or pull. So basically this is a main conceptual statement that push or pull on a body is called force, but we need to write in scientific way. So we need to use the scientific terms to write the definition of force. So any idea that how we write the definition of force in term of scientific quantities or physical quantities? Okay, I will
Like it can cause a movement in matter. I don't know any definition.
so that is a very good concept that we need to study, because we studied about the rest and motion state, right? And we know that
Yeah.
studying from the motion chapter, there are two different positions, two different states. So every time when we try to solve, or when we try to learn any new concept in mechanics, that is kinematics or forces, so it contains rest or motion state. So the basic definition for force will be like this, that force is an agent which produce or tends to produce produce the change in the state of a body, right? So generally we can say that helps to produce the change in a state of a body, just like if chair is at rest state, and if we try to push or pull that chair, so simply force helps you to change the state of a body, right? So if chair is in rest state and if you try to push or pull, so your state of the chair is going to be changed into motion state. And simply if we are driving a car and when we applies brake, so there is also force involved over there. So your state of the body is going to be changed from motion to rest, right? So this is the concept of force. And in this particular chapter, you already know about the resultant force, concept of resultant force, because normally we studied a single concept of force. Let's suppose only single force is going to be applied on an object. But let's suppose if more than two or more than two forces are acting on a body, so then we need to find out resultant force, right? So the next concept is related to the resultant force. Okay, for the daily life example of forces, you guys already know about the daily life example, so I'm not writing the examples in detail. You already have knowledge about the daily life examples that we already discussed. And after doing different topics, we automatically get different concepts that how we are can apply force and how force can change the state of a body. So basically for resultant force, we can just simply write it as resultant force is a type, or we can say that it is a single force. It is a single force that describes all the forces on a body. And we also solve some basic question related to resultant force in the topic of motion also when we are solving the MCQs question. Let's suppose if more than two forces are acting on an object, so you can simply identify by their direction, right? Let's suppose if one force is acting in forward direction, one force is acting in backward direction, so you can just simply add those forces. Basically when we are solving the resultant force, let's suppose if we consider a single object. Let's suppose if we consider an object over here, mass of object is equals to m. So one force that is natural that always act in the downward motion, sorry, in downward direction, which is known as the weight of a body, right? And what will be the
Yeah.
second? The opposite force, which
Uh,
act in the
Friction? No. Air resistance.
upward direction. First balance this force because object is at rest state, right? Whenever we placed any object on a table, let's suppose we place book on a table, so the weight of the book always act in downward direction, right? And according to Newton third law, action reaction law, we also discuss that law later, but you already know about that. When we apply some force on any object, so there will also be a reaction force. So that reaction force is known as normal force, right? Or normal reaction. So this red line represents you the second force, which is known as normal reaction, right? Normal reaction mean it is always in the opposite direction. Let's suppose if you try to push a wall, so you are not able to push the wall, right? Because that was a solid rigid body, so we are not able to push the ball. But consider in second situation, if we throw a tennis ball towards the wall, so it will bounce back. So why ball will bounce back? Because of the reaction force, right? So wall will also apply the same amount of force but in different directions. So same goes for the normal reaction. Because book is in a stable state, it means both forces are equal and opposite, right? And let's suppose if we
Yeah.
take a very little force or small amount of force in forward direction, so this is our normal applied force in forward direction, and book is not moving or sliding in forward directions because the amount of force is very much low. So you also get an other force in backward direction, which is known as friction, right? That resists the change in the state of a body. So that force is the force of friction, right? So now you can see that there are total four forces acting on a single body, but still object is in rest state, right? So the concept of a resultant force is, let's suppose if we mark them F1, F2, F3, F4. Let's suppose this is F1, this is F2, this is F3, and this is F4. Actually, you guys already know that how to add them, how to subtract them. Actually, the problem is that you need to learn the concept that we are not subtracting the force, because let's suppose if we apply some force, so there must be some quantity, right? Just like the length. That length can never be in negative value, just like time, right? Negative sign only shows you the opposite direction. Let's suppose if we want to find the resultant force, so your resultant force will be like this. Let's suppose this is FR resultant force. So that is the sum of F1 plus, now F2 is in the opposite direction. So we first add plus, then minus F2. Same goes for F3 plus minus F4. Actually, the concept is at this level, we are not taking important that why we are writing minus in a separate bracket form, but this is a very conceptual type of concept because this minus sign only gives you the concept of direction. This negative sign only shows you direction. This negative sign never shows you that the magnitude of the force is negative, right? So this is the only concept to tell you about in this form. Otherwise, you already know that how to add them, how to subtract the values, right? So this is only concept. And if you want to find out the direction of resultant force, let's suppose if someone asks you about the direction of resultant force, so how we can identify the direction of resultant force? Let's suppose same four forces are acting on a single object, right? And we consider one situation over here that F1, F2 are balanced, right? F1 is completely balanced by F2, but F3 is greater than F1. And now someone asks you to find out the direction of resultant force.
Wait, sir, F3 is greater than F1 or F4?
Sorry, F4. This is F4. So now you know that a body will move in which direction? In the direction of F3, right? So you know the resultant force that body will move towards or in the direction of F3. So that is the direction of resultant force. You can easily find out the direction of resultant force by the direction of the movement of an object. If body is in moving in upward direction, let's suppose. So so let's suppose if you consider a forces and F2 is acting in upward direction, let's suppose. So you consider that your magnitude of the force is greater. So that will be the same for the direction of resultant force, right? But in this situation, F3 is greater than F4. So body will move in forward direction in the direction of F3, right?
Yeah, so to the right.
Yes. So we can easily find out the direction with the magnitude. Uh, Initially we are only talking about the straight perpendicular parallel forces, right? We will also discuss, let's suppose if force is acting at different angle like 30, 45, 50, any angle. So how we can identify, because from if we move back in 22 or 21 before 23, syllabus was something different and there was a concept of to find out the resultant force in different angles. But in 23 syllabus, it is mentioned that you need to only solve 90-degree problems, right? Either parallel or 90, right? So we are not going to solve 30, 40 or any other angle. Okay. So we just need to solve perpendicular or parallel situation. Okay. So for simple situation, the direction of the resultant. So the direction in which object will move as a result of forces, right? So this is the state for the direction of resultant force, right? And magnitude you can easily find out with the help of equation number 1 if you want to find out the magnitude. Okay, any confusion till now?
No,
No,
sir.
sir.
Okay. And if we talk about the
Sir,
balance force, yes.
can you explain
Hmm.
the direction of resultant? I'm a little confused.
Direction of resultant means, let's suppose if I write the values for the same example, let's suppose this is example number one. And if we write the values, and your values will be like F1 is equals to, what is the SI unit of force? SI unit of force is Newton, right?
X Newton.
Yes, because we know there are three basic laws that we need to study related to forces. So that's why Newton is the SI unit of force. So let's suppose F1 is equals to 50 Newton, F2 is equals to 50 Newton, and F3 is equals to Newton, and F4 equals to 40 Newton. Because first we need to know about the basic concept, and we will discuss about 90-degree angle, right? So these are four forces, and first if we find out the magnitude, so for magnitude we just simply add all the forces to find out the resultant, find out the magnitude of resultant force. So that is very much simple. You simply add 50 plus minus 50 plus F3 is equals to 60 plus minus 40. So the final answer will be equal to 20, right? So basically, R is the magnitude of the resultant to 20 Newton. Now you need to find out the direction also. And one thing you observe, that one force is greater than the other force. Rest of the forces are equal, and 60 Newton is greater than F4. So it means that object will move in the direction of 60 Newton. So if you want to write the direction for this particular example, so you just simply write that your resultant force act 20 Newton in the direction of, you don't want to specify the direction like right side, left side, upward, downward. So you may also refer with the force or the symbol of the force that you already mentioned over there. So actually body is moving in the direction of F3, right? Because
Yeah.
F3 is
So I
great.
have a question.
Yes.
In the exam, will it ask us for like the definitions of like direction of resultant and
No.
resultant force?
In
Yeah, I thought
IGCSE or
so.
in O levels, they never ask about the definition, but sometimes they just give you statement and MCQs, or sometime in short question for in theory question for 1 mark, that complete the statement, or sometime they ask the definition. We never know for 1 mark. Just like in mass and weight, they sometimes ask the difference
Uh-huh.
like this. But it will help you in your A levels, because in A levels you need to must write the definition before every question. But in IGCSE, it is not compulsory that they always ask about the definition. So this is the concept of direction and the magnitude. And let's suppose if we talk about the balance forces, so balance forces means, let's suppose if two or more than two forces are acting on a body, and all forces are equal and opposite to each other, right? Just like the same, we discussed this example in initial stage, that all forces are equal and opposite, right? So that is the concept of balance forces. If we consider the example of tug of war, so tug of war is a very daily life common example in our life. So we observe that five people are on one side, five people are on the other opposite side, and both of them try to pull that rope in their direction. So when you get the greater magnitude, so rope and the other five people will move in the same direction, right? So that is the common example of resultant force. And one question that we already solved in past papers during the questions of motion. Let's suppose if we object, consider one object, and the second one, then the third one. So we are having three different objects mass M, mass M. The question will be like the same. Let's suppose if one force is acting 3 Newton towards right hand side and 5 Newton towards right hand side too, and Newton on the left hand side, 6 Newton towards the left. So in first situation, you can observe that on right hand side, we are having a sum of 8 Newton force, right? 8 Newton,
Yeah,
and same goes on the left
it
hand.
will be at equilibrium something.
Yes.
Equilibrium, no, rest.
Yes.
What's the term called?
Yeah.
Rest or equilibrium?
Equilibrium. Equilibrium.
Okay.
Equilibrium.
Uh, so object is at rest state, or we can say that in equilibrium state. So both statement will work for you. So equilibrium. If we talk about the forces, so for forces we can say that all forces are balanced, right?
Yeah.
Forces. And if we consider different magnetic force, let's suppose if one force is acting of right hand side and one force is acting 5 Newton on the other side, so we can just simply add them and your final is
5 newtons to the right.
yes. So simply 5 Newtons towards right hand side, Newton. It's up to you.
Also, so do we say the to the right or to the left? Because like it's different from our like point of view, and then the mass itself.
No, you just simply follow the direction of the force, the arrow. Arrow shows you right hand side, so you just simply write right hand side. Okay.
Ah, okay.
And let's suppose if multiple forces are acting on the body, so now you can easily identify. So no need for the third one. So basically, for the second example, these forces are unbalanced forces, right? Unbalanced forces.
Yeah.
Okay. Any confusion?
No, sir.
Okay. So if
No, sir.
same direction, you just need to add different direction. You just need to subtract. And one more thing that I need to add over here, we will discuss 90-degree afterwards. We are not talking about 90-degree right now, because first of all, we need to talk about some other other concepts. Then we will solve the questions related to 90-degree. In your past paper, you will find different questions regarding 48-degree, 50-degree like this. Yes, one more thing. Let's suppose if question says that draw a vector diagram. Vector diagram, you know that you need to draw an arrow with direction, right? Draw a vector diagram for two forces act in an opposite direction, and let's suppose force is equals to 100 Newton and force is equals to let's suppose 80 Newton, right? Okay, basically, there is a concept of drawing vector diagram of forces. Graphically, if we want, just like we draw a graph on x-axis and y-axis, right? So we choose a scale that how many boxes is equals to how many force or how many centimeter. So same goes for the forces. Sometimes they ask you in question to complete the diagram or to draw a diagram or a vector diagram. In MCQs also they used to ask about that, identify the correct vector diagram for the force. So let's suppose if you want to draw these forces in vector
Ooh.
form, so first of all you need to choose a scale, right? So first of all we need to choose a scale, and to choose a scale, you know that on paper on A4 sheet, that is your exam sheet, so you need to use a ruler to draw a diagram. And on ruler, which scale or which unit we are using, centimeter or inches? On ruler,
Centimeter.
centimeter. Normally we use
Yeah.
right? Because we have greater values in centimeter as compared to inches. Normal scale have around 6 inches and around 12 centimeters, like this 15 centimeters. So you need to write your scale in centimeters, right? Because we are not able to write in meter, because on our paper there is no space to mark a vector diagram in meters, so that's why we use centimeter. So we need to take scale in that form that vector diagram can easily be drawn on your paper. So let's suppose 10 Newton means we can simply write a scale as 10 Newton is equals to 1 centimeter, right? So your force 1 will be,
10 centimeters.
yes. So we need to draw 10 centimeter in any direction, because direction is not specified in the question. So 10 centimeter towards right.
Sir, on the forces, if there is no negative sign, how do we know which one is left and which one is right?
Yes, in question, it is not mentioned, because my main purpose is to how to scale the vector. So are learning that how to scale the vector. But in question, they specify with north, east, south, or they just give you specific example, or just suppose there is a picture diagram given over there. So we can easily identify direction, because they need to give you the specific direction. Otherwise, the student may solve in their own way, right? So in question, it is only mentioned that we need to draw in the opposite direction. So I choose 10 centimeter on right and 8 centimeter on left. So the main purpose of the question is to learn about how to draw a vector diagram if the values in Newton was given and you need to convert into centimeter. And in the examples on left hand side, like this example number 1, this example number 2, you observe that I also draw arrows in different sizes, right? So that is the concept. So normally they use different size of arrows to show the magnitude of the vector also, right? Direction is something different, but the length of the arrow also shows you the concept of uh, the magnitude of force, right?
Yeah.
Yes.
Any confusion?
So what about the thickness of the arrow? I remember some diagram like that. The thickness
Thickness,
of the arrow also.
actually thickness, there is no such concept related to thickness. We just need to draw
Oh,
in the
okay.
length, right? So thickness doesn't depend, because
Well,
we
I
are
must have seen it somewhere else. Okay.
okay. We will solve when we are solving the question, then we will talk about if somewhere there, but there is no such a specific rule regulation you need to follow for the thickness, right? Maybe that was some advanced application, but for your exam it is not compulsory. Okay.